Welcome everyone to today's presentation, Oracle Enterprise Edition, when nice to have features become necessity. A little bit about Neovera. We are a provider of hosted solutions, IT consulting, infrastructure managed services. We have clients ranging from nonprofit organizations to Fortune 500 companies. Founded in 2001, headquartered in Reston, Virginia. We're vendor agnostic, and we do provide 24/7 on-site customer service. Some of our offerings and capabilities generally around IT consulting, database services, managed services, cloud solutions, and data center services. We have co-located facilities, 24/7 NOC. We provide the services around managing anything from the infrastructure, application, backups, database administration, disaster recovery. We support a variety of databases for Oracle, SQL Server, MySQL, and we do provide cloud solutions, whether it be private, custom, hybrid, and we do support and manage dev and test environments as well. A little bit of background, my background. I am an Oracle certified professional. I've been working with Oracle since version 7. I've done everything from database administration to architecture, modeling for a variety of different industries. I also have a patent in healthcare predictive analysis. I've spoke at various Oracle users group, done speaking at training days, and I've also taught most of the DBA and PL SQL classes. Worked in environments from Standard Edition 1 all the way to Enterprise Edition, single instance to multi-node RAC with active-active replication between multiple data centers, and also RAC over WAN. And in that role, I've worked just about with every type of database, whether it be application-based, data warehouses, data marts, etc. As part of this presentation, we're going to mute the phones, but feel free to type your questions in the text box, and I will actually get to those questions at the end of the presentation. So a little bit about what we're going to talk about today. So really this is going to be geared toward those who either have Standard Edition today and are looking to upgrade to Enterprise Edition, or if you don't have any Oracle today, but you're kind of considering which edition you should purchase. Some of the things we're going to go over today might help you in making that decision. A lot of these things that we're going to talk about, although not an exhaustive list of Enterprise Edition features, it is the ones that we see with our clients that are the most compelling or driving factors in the investment in Enterprise Edition as opposed to Standard or Standard Edition 1. Some of the topics that we're going to cover are going to be relative to the performance, some of the performance features you get when you have Enterprise Edition, the high availability features, some of the additional security features that are available, and some of the operational concerns you may have. So starting with performance, these are the high-level ones that we see are the most compelling. From an application standpoint, being able to use client-side query caching to get performance results on an application side. Query results cache, another variation of that where that's actually cached, data's cached on the server side. The use of partitioning, both for performance and for manageability of your data. Data compression, and the use of parallelism with different types of SQL statements, whether it be exports, imports, backups, recovery, DML, DDL type statements. So the first of that being the client-side query cache. So what this actually affords you to be able to do is cache the data in the client side. So from a multi-tier application, that data can actually reside on your application server so that you're not making these round trips back and forth to the database. It's transparently kept in sync with the server-side data, so you don't have to worry about whether or not data is changing, and that client cache memory is in sync with the server data. Those are processed locally through the OCI calls, and so if you're using the JDBC, OCI, ODP.NET, OCCI, ODBC, Percy things, that is available to you. It's primarily used for static and read mostly data, and the result sets are large, but the return rows are small. So what that affords you to be able to do is, if you have applications that rely on aggregated data, and that data result set is small relative to the size of the total size of the table, then you can get a huge performance increase in being able to cache that on the client side. It also can be used for lookup tables and things like that that are very common in applications. It allows the developers to annotate that with a result cache hint, so you have control over what you want in the client-side query cache. There are some limitations about what can be cached as a result of result sets from views, remote objects, any PL/SQL functions that return result sets, and for flashback queries. But this can make a big difference in the performance of the application side of it. Likewise, you can also cache these results on the server side. So it's a separate memory pool that resides in the SGA, part of the shared pool. And that's set aside to mark tables or result sets that you want cached on the server. So it's separate from your buffer cache. So good candidates, just like on the query side, SQL that accesses large data but returns a small number of rows. Again, in a like a data warehouse solution, where you might have an application built on the results of that, maybe dashboards or things, that those results can be cached and provide significant return on performance. The database will automatically look in that cache for the results first. If it's stored there, then it actually uses it from the cache. Otherwise, it'll actually fetch the rows and put it in the cache for the next execution. You can actually see whether or not this is being utilized from a explain plan standpoint. It generates a object name or a cache ID that you can see in your explain plan noted here as a result cache. You have a control over that result cache on the server side with some initialization parameters, so you can specify how much cache is going to be used, what's the maximum results, what is the time or expiration on that data in which that it needs to be refreshed or aged out, and you have control over whether or not that cache is used automatically or manually, meaning you could actually set it to cache everything, not recommended, or you can actually use the manual mode where you specify what it is you want cached. So you have some control over that, and you can see what the effective use of that cache is with some data dictionary views. You can see the dependent objects, so it'd be like the base table. You can see how much memory is being used, how many objects are in the cache, and statistics around how that cache is used, whether it was retrieved from there or whether it actually had to go back to the database for that. And Oracle does give you a cache memory report procedure or package that you can run that'll actually show you how much the cache is currently using, how many blocks are actually put in the cache, and the actual percentages of that relative to your total memory. So again, this provides pretty good results for those objects that are frequently used, aggregated data, things like that. Next subject is partitioning. So it doesn't matter whether you have a 50 gig database or terabyte database, partitioning adds value in the performance and maintenance side. So it basically takes your large table, a large table or index, and decomposes them into smaller, more manageable pieces. So it's more of a logical thing to the application. It's transparent in the sense that it doesn't know how many partitions exist for a particular table. It just queries the table. On all the individual partitions are then accessed depending on how you actually partition it. So different types of partitioning, you have a lot of flexibility in how you define these. You can do a range partitioning where you actually specify a beginning and ending value. So if you did something like a date, you could put each month into a specific partition. So rather than querying a year's worth of data or 10 years worth of data, you can actually put the data is put into smaller units of work so that you're not querying the whole table. A hash partition, if you don't really have a good way of specifying specific data for a partition, but you want the data to be evenly distributed across multiple partitions, then Oracle will apply a hash function to whatever key you define and split that up into X number of partitions. So you can say, I want 50 buckets, and you'll know that all the partitions are pretty much evenly distributed for the data. You can do a list, so you can actually specify individual values to exist in particular partitions. So you could do, if you were partitioning by, let's say, a state, and the data is not evenly distributed across every state, you could actually control which data for those states are in which partitions. So it gives you some flexibility in how to subdivide your data up. Interval partitions. So this creates partitions as needed. You have to use a number or data type for this to work, but basically it will create the partitions on the fly as the data is put into the tables. So if you had gaps in your data and then later you inserted data that would fall outside of the pre-existing partitions, it would automatically create that new partition to store that data. So a lot of maintenance overhead with partitioning is eliminated with this. Reference-based partitioning, so you can partition based on the actual primary and foreign key relationships of tables. So as data is inserted into a parent, you may have the child table partition based on those primary key values from the parent and automatically have the partitioning done for you. You can also do virtual columns. So this is the case where you define a column expression on a table, then you can turn around and partition based on the results of that expression. And then of course you can do composite, which is a combination of some of these different types, like a range hash or a hash list, things like that. So a lot of flexibility in how you define this. So this is kind of key from the very beginning when you define these tables, how you do this partitioning. There's always the trade-off of partitioning performance versus manageability. And what I mean by that is if you have a situation where data becomes old or history-like and that needs to be put on slower storage for a cost standpoint or data lifecycle management, you would balance that with how you partitioned it based on application access. Some of the benefits is obviously performance. So taking large tables and pruning them down into smaller sets of data so that your application's not looking at 1,000,000 rows, it may be looking at 1,000 or 100,000. It can also benefit you if you're joining parent-child tables and both the parent and child have partitionings. So there's some performance increase in the joins of those two tables based on how those are partitioned. The manageability is more of like a divide and conquer approach. You can actually create rolling window data loads so that you're not loading into a 100 million row table, you're loading into an empty table that then becomes a partition of the table. So there's some benefits there in situations where you might have a data warehouse. Loading into a table that is empty with no indexes is much more efficient than loading into a billion row table with all the indexes that might be there. Once that table's loaded, then those indexes can be added to those partitions. Also, you're able to back up single partitions instead of the whole table, so there's some performance benefits in being able to say, I want to make a copy of this particular set of data, which resides in a single partition, rather than copying the whole entire table or selecting the whole entire table to find the smaller subset that you want to back up. And of course, availability. They're actually stored separately, so those could be on separate table spaces. Those could be put into read-only mode. You can actually do things with the individual partitions that you can't do with the base table, meaning if a particular partition needs to be taken offline for some reason, then it doesn't affect the entire table. Only that particular partition's data is affected. So the application can continue to work while you're doing maintenance on something else. Compression. So some of the features that we're talking about are either in options in Enterprise Edition or built into Enterprise Edition natively. And compression is one of the ones that has kind of a mixed, whether or not you have the advanced compression option or not. But you have network compression for data guard. So if you're running standby databases, you can use the compression across the network. So obviously this results in better performance for maintainability of your data guard or your standby databases. You can use it for data pump compression. You can use it in your backups. You can actually specify it on tables to do similar. There's different types of compressions on the table, but one of them is OLTP. So you can actually reduce the size of the storage required to maintain some of these tables, especially where the data, there's a lot of redundant data values. And then I think one of the better features available in 204, if you're 11.204 without the history table optimization, is this flashback data archive. So this is actually being able to keep track of data changes in a history table. Prior to this, most DBAs would set up, or your only option was to set up a separate set of tables that were populated some kind of way, either through replication or through triggers. Well, the flashback data archive gives you this ability natively. Very low overhead and maintenance required. So I think this is one of the nice to haves that becomes a necessity when you're responsible for maintaining history of data changes over time for compliance. Parallelization. So share everything approach. This is unlike most MPP systems where you actually have to have a node that has a dedicated storage and each node looks at that storage only. Oracle takes a different approach where all nodes look at the same data, and then how the parallelism is done is a little bit different than those other systems. Some of the other RDBMSs actually use the share nothing approach. Where you could use parallelism is in SQL statements, both DML and DDL. So if you've ever done large full table scans, obviously running that serially is much slower than if you can break that up into smaller processes working on that data. Data loads, so this is where you might be doing lots of inserts or transformations on the data. Doing that in parallel is much faster, or can be. And then rebuilding indexes. If you've ever had indexes on 100+ gig tables, you know that index times could be substantially slower than if you were to be able to run multiple processes against that, and gathering stats and things like that. But mostly these are the two that we see. Also, you have the ability to do statement queuing. So this allows you to have a more predictable performance when you're using parallel processes. What we do see sometimes is the use of parallelism actually hurts systems because it's either misconfigured or no configuration was done to control how much parallel processes are used within a particular statement, and obviously that can overwhelm your system. So if you kind of went overboard with parallelization, you would actually be slower than if you ran it serially. And again, that is just because lack of knowledge or not knowing exactly what the resources are in the system that the parallel processes are consuming overwhelms the system. You can also use it in RMAN backups and for recoverability. So if you're running multi-terabyte databases, obviously running that serially can be very slow, especially if you have large data files. Being able to do that in parallel, and if you're using real application clusters, being able to distribute that across all nodes makes a huge difference in the time it takes to do full backups. And then of course data pumps for exports and imports, being able to export out larger tables in parallel is obviously faster. And parallelism actually complements partitioned objects. So in the case where you have a table that may have 100 partitions, being able to hit all those partitions simultaneously with parallelism is a huge benefit. On the high availability side, the two that I'm going to talk about is the real application cluster One Node and then Data Guard. And again, these are not the only things for high availability with Enterprise Edition, but it is the things that most people would consider if they were looking at going to Enterprise Edition and wanted some of the features that you wouldn't get if you didn't have it. So not used as much with most clients, but certainly it has a good fit from a cost standpoint and high availability standpoint, is the RAC One Node. This is basically like a real application cluster in an active-active, except it's active-passive. So it's a single instance with the ability to fail over from one node to another. And you can use that when you're doing instance migration, so moving that instance. You might be moving that for purposes of upgrades, being able to move it for load balancing or for resource management. So you have a pool of active-passive servers, and you want to be able to move the single instance database through that pool to where maybe it's least loaded or not being used, so that you can do an online role upgrade. You define these pools that are more policy managed. You can actually ensure that the instance gets the resources it's needed by using instance caging. That'll guarantee that when that instance moves over to another server in the pool, that whatever CPU that it was using in the previous node, you can guarantee that it gets that same resource on the new node. And then again for load balancing. So multiple databases, being able to move them between nodes live is for the load balancing side. And the benefit of this is for maybe not necessarily like a server failure, but in a planned migration, the sessions actually move with the database or the instance. So in the case where you have applications pointing to an instance and you're ready to upgrade that, let's say you're upgrading the OS on that, or you want to upgrade the Oracle version on that, you can actually migrate that over to another server. It'll actually create another instance, and both instances for a short period will be live at the same time. It'll wait for the active sessions to commit their work on the first node, and when that's done, those sessions will automatically be migrated over to the new node. And once all those sessions have become inactive, then that instance will terminate on the first node. And then you can do whatever maintenance you need to do, but it's transparent to the application that you're able to do this. Oracle Data Guard. So this is basically your managed standby database. It's used for most people use it for disaster recovery or for data protection, where you actually have a standby database. You may or may not have a lag time built into that to support human errors on the primary server. You'd be able to go to the standby and do some sort of recoverability there based on how you've set up the protection modes and if you've instigated any kind of lag times into that. It's also used for offloading your backups. So you can use the standby database to do your backups, and you can also do read-only reporting from that instance. So you have a little bit of availability with offloading CPU or IO intensive operations to your standby server so that you're not impacting your OLTP system, let's say. And if you purchase the active data guard option to that, you can actually do real-time querying on the standby. So with most standbys, whether it's physical or logical, that is read-only for that data to be applied. Active data guard gives you the ability to be able to have that database open and active while that apply process is actually running. So in the case where you do physical or logical, the physical is a block by block apply. So the database is not actually open. Users can't connect to it and run any kind of queries. You can still do backups and things, but the ad hoc users or reporting users can't make use of the instance. On the logical side, though, the SQL, it turns all those operations into SQL statements that get applied. So it's not doing it on a block by block basis. And now the database can actually be open and used by reporting. The objects that are being accessed that are part of the replication between the two is still read-only, but you can at least query it. You can actually add additional schemas or other things into that database that are not part of the primary database. So a logical standby could then be used for something else other than the data it's getting from the primary. On security, talk about advanced security, some of the options you get if you have the advanced security option. One of the, I think the most exciting pieces is the data redaction, and we'll talk about that. That has a lot of useful benefits if you're dealing with HIPAA, PHI, PCI type information, and that data needs to be obscured. The data redaction eliminates a lot of the manual processes that most people go through, whether it be masking the data through the application or actually creating encryption on it. This actually is much easier to implement and provides the data security even when the data is accessed outside of the application. I think that's the biggest one. And then we'll talk about virtual private database and fine-grained auditing. Again, these are some of the bigger ones we see because organizations get into the case where they need to have some sort of compliance, regulatory compliance, and security around their data without developing this whole framework yourself. So with advanced security, you get some transparent data encryption for your columns. You can do it on table spaces, secure files if you're using that, and of course your exports and backups can be encrypted. So a lot of times, even though applications may encrypt data, you still have the whole of someone exporting the data out and taking that data off-site. That's unencrypted, and now you've exposed yourself from a compliance standpoint. And also backups, if those backups have to go off-site. You've now exposed your backups to potential data breaches if it's not encrypted. And then data redaction. This is actually available in 11.204. So you would need to be at this release to at least take advantage of this if you're not going to Oracle 12c. And then of course you have network encryption. It used to be part of the advanced security option, but now it's available in all editions. So if you have a requirement to encrypt the data in the actual flow between the client and the server across the network, you can now use different encryption methodologies here without actually having the advanced security option. Data redaction, again, available starting in 11.204. This gives you the ability to set up different types of methods so that your data is actually masked to the end users or to anyone looking at the data. And some of the methods here is you can do a full mask, which basically masks the entire contents of the column. You can do a partial, where, let's say for a social security number, you only want to show the last four. You can actually mask the first set of data and only retain the last four for viewing, end user viewing. You can also apply pattern matching using regular expressions, so where your data is not exactly formatted a certain way all the time, you can actually run some expressions against that to actually pick out different pieces of the data to mask or apply expression to it to find the actual data. And then you can do random, where Oracle's just going to generate values every time you access the data. So in this case, every time you select the data, you can get a different value, but there are some pretty cool features around being able to maintain the skewness of the data. So if you had X number of values that you need to mask, Oracle will mask that data, but somewhat maintain that data skewness. And then the redactions applied at runtime, so your SQL execution time. So when they actually select the data, that whole redaction process is applied. And again, this is more useful in the cases where there's regulatory compliance around being able, who can see and what they see of the data. Again, PCI, SOX, HIPAA, etc. And of course, the SysDBAs, obviously, they have a grant given to them to exempt them from a redaction policy. So your Sys user or your SysDBA users can still look at data or do something with the data on behalf of others. There's ways to even lock that down, but just standard data redaction, your SysDBA still have access to that data. Virtual private databases, so this is where you can actually create security policies to control the access of that data on a row or column or row and column level basis. It operates against tables, views, and synonyms. And basically what it does is for every SQL statement or for that security policy, we'll dynamically add a where clause to it. So whatever where clause based on who can see it, what they can see, when they can see it, you apply that dynamically at the time the data is accessed. And those policies are actually attached to the object. So there's no way you can actually bypass the security. So you can't have a grant given to you, let's say through an application, and that application enforces the policy, and then go into SQL Plus and bypass that. Even if you go into SQL Plus, that security policy is applied. So that's a major difference in how security is generally done at the application level. So not everyone creates a database user for every application user. That's generally handled in a framework that's outside of the database and applications. The problem with that is the users that do have those permissions could actually, if they had a database account, could go in and circumvent the application security. You won't be able to do that with the virtual private database. And it's really useful in multi-tenant database applications. So this is the case where you have multiple applications hitting the same set of data, and you're managing those permissions independently of the database. The virtual private database will ensure that the security policy is enforced no matter which application is using that data. So some reuse there is beneficial. And then you have a lot of flexibility in how you define these policies. You can actually have a policy for select that's one thing, but for insert and update and delete, it's entirely different. So you can make it more restrictive for the insert, update, deletes, and a little bit less restrictive on the selects if that's your case. Also, the ability to do fine-grained auditing. So this is policies that are defined the actual condition under which an audit occurs. So it may not always be enough to know that someone had used the select privilege to look at a table. So that's what you would get standard auditing. You wouldn't know under which condition that auditing occurred. It's more broad. Well, with fine-grained auditing, you can actually monitor the access data based on the actual content of the data, what time of day it was accessed, any kind of metadata, meaning which server, which IP, which client came and looked at the data. If they're actually modifying a specific value in a column, all of those things can trigger audit records. And when that auditing occurs, it actually stores the SQL that was used to access the data and any of the bind values that were used in that SQL statement will also be recorded in that audit table. So this is auditing that could really provide auditors, compliance auditors, with the information they need to know that that data is not being circumvented. You have a record of every access, who looked at a particular record. So this would be very useful in cases where companies store PCI type data or HIPAA compliance type data. And it supports event handlers, so you can actually attach to that auditing the ability to send notifications based on what type of audit that was. So in the event that maybe somebody looked at a patient record, that could automatically send an email saying what they looked at, it's specifically what they looked at and who it was that looked at it. So again, huge for compliance audit. Some of the operational things for Enterprise Edition, again, these are the ones that I see that are most useful, the ones that are the driving factors. Online maintenance, whether that be table or index. So if you're using Standard Edition and you want to add an index and that's a large table, obviously without Enterprise Edition, you need to be able to do that in either an off period or a time when the application's not accessing that data, because it's going to result in locks on the table. Some organizations don't have the flexibility of having a 9-to-5 schedule. They're 24/7 around the world that's being accessed. So being able to add and do maintenance on indexes and tables on the fly, real time, huge benefit. Being able to do duplex backups, do block change tracking. If you have a large database and you're doing full and incremental backups, you want to be able to increase the performance, the time it takes to do those incremental backups, the block change tracking. Being able to do block level media recovery, loss right protection, parallel backup and recovery, point in time recovery, flashback operations outside of flashback query, which you would have normally. Enterprise Edition enables you to be able to do that at an entire database transaction or table level. And then some of the diagnostics and tuning packs that are only available with Enterprise Edition. Not so sure why they excluded the Standard Edition from that, but huge benefit in being able to do AWR type reporting and SQL tuning from if you're using like grid control or cloud control. More resource management, being able to define how resources are used, when they're used, and being able to manage the priority of that resource usage. Instance caging, again, we talked about that, where you can actually dedicate and ensure that instances get specific CPU cycles. And then SQL plan management, where you might want to create profiles and things on your SQL statements to ensure that they get a consistent and predictable execution plan. I put Oracle 12c in this presentation because those that are considering Enterprise Edition straight from the newest release, brand new, you can also take advantage of these. Or if you're looking to upgrade and you're going from Standard Edition, maybe an older version, and you're considering at the time you go to Enterprise if you want to implement 12c, these are some of the newer features that I think are probably more related to being able to make a decision about Enterprise Edition. One of them is the online data file move. We'll talk about that in a minute, but you can't really do that outside of 12c. It wasn't available until 12c. Transaction guard, recovering a table from a backup, making use of adaptive execution plans, real application security. This is a really cool one. We'll talk about that one. And transparent sensitive data protection. So this is an add-on top of what we already talked about on the data redaction. This one actually allows you to do a lot more in conjunction with either the data redaction or the virtual private database. Online data file move. So this allows you now to be able to move a data file while it's open and be in access. So if you're moving data files between different file system mount points, if you happen to be one of those DBAs that are managing your actual data files in individual mount points and trying to load balance that, you can now do that online. You can use it to move files from file systems to ASM. If you're looking at migrating to ASM, you can actually move it between storage devices, relative, same thing as moving between your file systems basically, but you can also move between maybe less expensive storage for data that is history or read-only at that point. You might want to be able to move those. You don't need to take an outage to do that now. Makes a copy of the file, updates the control file and the data dictionary when the operation is completed. So you have control over whether or not during that process, if that old file is retained. If you're one of those extra cautious people and you don't want to just move it and the old one go away, you want to retain the original until it's done, and then you manually do it, you have that ability, capability. Transaction guard. So this is where your application needs to know what the outcome of the last transaction was. So in the middle of app servers doing work against the database goes down. Your applications need to know at what point was the work committed. At what point during that workflow did you actually do something in the database and persist it or not? So a break between the client server traditionally now, or prior to this, is not durable, meaning you don't know exactly where in that process it could have committed or not committed. So failure to know that leads the application to be able to duplicate data or duplicate the transactions. So from a compliance standpoint on data, especially if you're dealing with like trading systems, healthcare systems, not knowing whether or not the application completed a full unit of work would be a bad thing. This allows you to actually detect that, use that information to recover or reapply transactions. So the database will actually generate a logical transaction ID for your transaction and persist that in a history table. And it'll maintain that by default 24 hours up to a maximum of 30 days. And that's all configurable by the DBAs or by whomever is setting up the transaction guard. So in this case, there's huge benefits in the applications being able to respond to any kind of outage between the client and the database. Being able to recover tables, I think if you've been doing Oracle long enough, you've always got into a case where somebody accidentally either dropped or truncated a table, and now you have to recover that table. And you have to recover it, and you don't have the ability to use some of the flashback features because of DDL that might have been performed against it that would preclude you from doing that. In the old days, what we had to do is go get a backup of the database, create a minimal set of required files for recovery, open it up, do the recovery, open it up, and get the data out to put back into the other system. Well, that whole process of recovering that table that you would have done manually is basically automated for you. It's the same steps, it's just that Oracle does it for you. So you actually specify what you want to recover. Oracle will automatically create an auxiliary instance using only the files needed to get that particular object out. It then turns around after it's recovered it. It performs the data pump for you automatically. And if you haven't specified that you want to stop that process there, it can also turn around and take that data pump export, import that table for you, and put it into a whole new table at the same time, so that you can kind of do comparisons if it's a subset of data that was removed. So this is useful, like I said, whenever you can't use flashback, table might have been dropped, purged, so you can't even flash back the table. Or if flashback's not available, even if you do have the ability to use flashback, but the retention on your undo is the data is no longer there. So this is useful to recover tables from your actual backups. Adaptive execution plans. So this is a case where your execution plans can actually change. Oracle will actually change those and adapt and dynamically improve them based on your runtime statistics as the system evolves. So the biggest improvement is when you look at an explain plan, and it shows that the optimizer is estimating a number of rows that are actually significantly different than the actual number of rows. So the optimizer, if you mess with the execution plans before, you know that the optimizer will make an estimate based on statistics that it has about how many rows a particular plan step might do. Sometimes that estimate is drastically different than the real number of rows that are going to be returned. So the adaptive execution plan allows Oracle to see that skewness between estimate and actual is big enough to constitute a change in the plan. And then it will actually change and generate a new plan at runtime. And so you can, and if you've looked at $sign SQL area and you've seen SQL statements, and it actually will generate a new child record for that SQL with a whole set of different plan statistics. It shows up in your explain plan as a statistics collector. It'll actually show in the explain plan where the original statement, it considered all the original statement steps, and then it actually comments those out, so to speak, to show you that based on runtime statistics, it ignored those steps and went with an entirely different step. It does require statistics level to be set to all. Most databases are, by default, they set it to typical, but you would need to increase that to all. And it can run in reporting only mode so that you can actually see what those plans would have been changed to without actually having them change. So there's some configuration the DBAs can do to say, I want to see what the adaptive execution plan and that optimization would do, but I don't actually want it to do it. So you have some control over that. Real application security. So this is a feature that basically would eliminate the need for applications to develop their own custom application or authorization scheme. So traditionally, applications are the ones that control those security, that whole framework. What this allows you to do now is actually move this to the database. So instead of you creating the whole table-based username, password, authorization, authentication, and permissions for different objects from within an application, you move it down to the database, and the database can enforce it globally. It gets that application logic and moves it to the database. So the premise of this is that you're actually going to be managing application users rather than database users. Not everyone, like I said, goes out and creates a database schema or database user for every application user. So this allows you to manage that security for specific application level tasks. And it enables the user identity during that security enforcement, so those users are carried through the system. You actually configure entities, and those are actually stored in tables on the Oracle side. So when I speak of entities, I'm talking about application users, the roles, the privileges, the actual sessions for those applications, any principles of the access for that, defining security classes, and data realms. So really the whole three-dimensional security model that's in applications today moves into the database. And you make use of that with access control lists and control entries. So this is kind of, when I say three-dimensional security model, this is basically a high level of what it looks like, where you can actually create users and roles. So in this case, I'm using a patient-doctor facility or clinic model, where we actually have a doctor, we have a privilege to be able to modify a patient record, and within that patient record is stored at a specific clinic, and using an access control list, we now can actually grant that specific privilege to a specific user or role only when it pertains to this specific type of data or data from this location. So a more comprehensive security model implemented at the database level. This would be huge to remove all this application logic and be able to move it to the database when there's multiple applications that have some commonality in its access, its users, its privilege, and the type of data it looks at. You now don't have to worry about, did you get the security model and privileges right across all applications? It's more unified in one location now. Transparent data protection. I said this kind of works in conjunction with the data redaction or the virtual private database, but this allows you to actually create policies to protect sensitive data based on a classification of data. So if you have a database that has credit card numbers, and that credit card number can be in many different tables, you're now not going to it. You can actually create a security class around that credit card number type of data and apply that to the entire database. And if using some of the features of grid control or cloud control, it'll actually find the data in your database that matches that type. So this is the case where you say, find all number data types that have a length of 9. This is considered sensitive data because that is our data type and length for Social Security numbers, let's say. You can apply it to a single table column, all table columns that satisfy a certain protection policy. So it's a broader implementation of the underlying data redaction and virtual private database. It actually can protect the data that's in bind variables. That's useful in the case where that's being stored in audit trails or trace files, so that you don't have exposure of that data sitting in file system files somewhere that someone then could actually look at. And the policies can actually be exported and imported in another database. So you can set up this policy in a specific database. You have another database that has, maybe it's for, if you've segregated your data into multiple clients have their own database, you now can define those policies and move them between the databases so that you can ensure that that sensitive data is protected consistently across all your databases. So those are some of all the major features that we see are the compelling reasons why clients move or consider the move, investment into Enterprise Edition. There's always more than one way to do things. Obviously in Enterprise Edition though, those things are inherently built into the database feature set for you, so that eliminates you being able to develop these things on your own. And as far as our company and what we do in conjunction with clients that have Standard Edition, Enterprise Edition, moving from Standard to Enterprise, we provide expertise in mainly in these primary areas around RAC, Golden Gate, if you're doing replication, if you're doing any kind of Apex applications, the middleware side of it, and Exadata machines. We actually provide that type of consulting or expertise in helping you design, architect, manage, and maintain that. Whether we're assisting you or we're actually doing it, that's where our expertise comes in. Some of the other database services that we provide, not just database administration, we do DR sites, we do database security where we actually monitor and maintain those security and auditing. Those are for clients that have strict regulatory compliance. We help them to maintain that kind of compliance for auditing, external auditing. And then we also do, outside of database, we do everything with the storage and the monitoring of that, whether if you're on ASM or file system, manage what I would consider typical operational database tasks. We are a gold partner. We do resell Oracle, although that is not our primary goal. Our primary experiences is actually in the database products. We make recommendations on what software you should have. So if you are new to Oracle and you don't really know whether or not you need standard edition or enterprise edition, we can help educate you on what those features are and how they may apply to your business and what might be the most cost-effective approach for you, especially if you're looking at DR and HA and adding those things in. And some of the things, common things that we do as part of that is we actually do an assessment of whatever your assets are to see where Oracle might help in managing that. We do upgrades, patches, roadmaps if you're designing your short-term, long-term roadmaps for your data assets, security compliance, 24/7 monitoring. Like I said, we have a 24/7 man, nothing goes unnoticed for the database, and multiple escalation tiers within that. So with that, I'll take any questions you might have. If you've typed in your questions in the text box, I will pull those out one by one and start to answer those. And if you have no questions, I want to thank you guys for attending the webinar. I hope it provided you with some sort of knowledge as to making a better informed decision about whether or not enterprise meets the needs and the cost justification. And if any of the extra features or you recognize within your business that those are necessities, hope that provided you some extra value. Thank you for your time. This concludes this seminar.